title of this evening's webinar is titled Machine Learning and Business Analysis. Our facilitator today is Steve Blaise. He's an author, a consultant, a teacher, and a coach. I don't know if anyone is very familiar with Steve, but I am. I've used lots of his resources. It has helped me in my work. I've used it to help other people. And I love listening to joining any webinar I see he's facilitating and learning. I never leave without learning something new. So help me welcome Steve today. In fact, I remember when I was trying to send the email to invite him for this event, I was like, will I get a response? And I almost got a swift response, and that really touched my heart. Thank you so much, Steve. So Steve has over 55 years experience in information technology, working as a programmer. He's worked as a project manager, a business analyst, a systems analyst. He's also worked as a general manager and a tester. He is the author of Business Analysis, Best Practices for Success, which is, we are going to have 2 winners for that book. He's also the co-author of Business Analysis for Practitioner, a practice guide. You can find this on the PMI website. Very, very great resource that I have used and I still continue to use. He's also one of the contributors to the Business Analysis Body of Knowledge, BABOK, the BABOK version 3. He has a new book coming out later this year titled The Digital Transformation of Business Analysis. So please look out for that announcement. Without much ado, Steve, I'm going to hand it over to you right now to take it over from here. Thank you once again.
Welcome, everyone. And I'm pleased to be here. And thank you, Olga, for inviting me to your chapter. We're going to talk about machine learning. I get a lot of questions. I've been around for a long time, long before the term business analyst was even used. Back in the 60s was when I started in IT. It was called data processing back then. So, and I get a lot of questions. The most current, I kind of keep a little bit of a track, and the most popular question I get is, Steve, how do you ask the right question? And but usually there are questions, well, there's something new happening. What is that going to mean to the business analyst? And lately, for the past, year or 2 years or a little longer, the term machine learning has been coming up, and more so in the past couple of months. What does it mean, or what is it going to mean to the business analyst about machine learning? Now, I should say that machine learning itself is not new. The machine learning has been around for quite a while. It's just that we're starting to use it for various different things that we didn't think of using it originally. And that's where the business analyst is going to come in. So let's look. Here's your business analyst. You might recognize yourself there. There's a business analyst. What's a business analyst typically thinking about? Well, they think about requirements. So they're asking, what do I have to do to define the requirements for this product? Where am I going to get the information? Who am I going to talk to? Who's got the answers? The stakeholders just keep changing their mind. I've been back to them 4 times and they give me 4 different answers. How can I get the requirements written if they keep doing that? They keep changing the requirements on me. Come to think of it, gee, this thing is due on Friday, so I better check the spelling and stuff, because they're going to be so wrapped around the grammar and spelling, they're going to forget about even checking to see if the requirements are right. And who am I going to be talking to next week? And I need a new appointment. Well, that's the requirements that's been going on for 3 decades now, where we've been looking at what's going on, getting the requirements, getting the information. And that's cool. Back in the early days, we had requirements. And when we developed the requirements, it was directly with the users. And they would tell us what we wanted, and we would write them down. We'd write some code. I would write code. I was a coder back then. I'd write the code and they'd look at the results, and I'd lay it out on a 5081 card and I'd put the data on a mag tape. And then eventually they'd say, yeah, this is what I want. And fine, we signed up and go away. That was the requirements. Eventually, though, we started writing the requirements up front for various different, mostly political reasons. And the requirements were used to size the projects. Can you imagine that? Can you imagine being told, we don't have a project yet. We don't have a deadline. We don't have a budget. I want you to define the problem clearly and go get the requirements. Define the requirements for this. What is it going to take to solve it? When you finish that, and we say, yes, we'll do this, that's when we're going to put the cost on it, estimate the cost, and estimate the time it'll take. Well, for one thing, we've got a lot more accurate estimates. Now, it sounds more like this. Hey, Steve, we're doing this project. This is what we want done. This is the deadline. We need it by 3 weeks from tomorrow. And we got a budget here. You got 2 people. Go find the requirements. I already defined it. Everything's done. All I have to do is get the requirements to code it. And that's kind of what has evolved with requirements. And there you are sitting there figuring out, how am I going to get these requirements? Well, let's look at the conundrum that we are under as business analysts today. Now, this is all relatively new. I didn't have to face this way back in the 60s, 70s, 80s. So here I am saying, where are the requirements? Someplace out there, there's the requirements that I need. Someplace out there is the answer, the solution to this problem, and the steps I need to do, I need to tell somebody else to do in order to solve that problem. Well, they're in, documents, big stacks of documents, fold 3-ring binders that are 8 inches thick, written 20 years ago. And it says right there on it, requirements for the accounts payable system. Or maybe it's a use case. Or maybe it's stuck someplace in all the data we have in the data warehouse or the transactional data stores. Perhaps the requirements are on emails, text messages, voicemail messages, recordings of meetings. Well, that's a little bit more difficult to find. The videos of meetings, perhaps. Maybe they're in a product backlog on any number of agile Scrum teams, or perhaps they're a document or a bunch of use cases, or all of the above. It's gotten very voluminous, and back in the day, we had Word or some word processing. Well, actually, back in the day, we had typewriters, but we'll advance it a little bit further. So there wasn't that big a place to look. And we had a select group of individuals called stakeholders or users, and we talked to them. Now the requirements could be anywhere in the organization. And see, this is where something like machine learning comes in. Now, using machine learning internally is a good idea, and we do. And you say, well, I'm familiar with machine learning, Chat GPT, right? So why can't we just go in here and say, hey, Chat GPT, like, hey, Siri, hey, Alexa, go in and find me all the requirements I need. Well, unfortunately, we can't do that, which is why I'm not going to be spending a lot of time telling you how to use and write prompts for Chat GPT. If you want to know that, that can be done. But right now, you're working in-house. We don't have your data out there. Chat GPT probably does not have access to your data. It's got access to all the data in the world, but not from your company, unless you posted it out someplace where it could get to it. So you want to get the requirements in your company. Can't say, hey, go out and find them for me. But you could use machine learning. See, machine learning is out there. It's a subset of artificial intelligence. And artificial intelligence, you think I'm old, artificial intelligence was first introduced in 1947 and then officially in 1954. I was a wee thing back then. I probably couldn't say artificial intelligence. It's evolved over time, mostly in academia, mostly in colleges, universities, and research centers and so forth. They did the artificial intelligence. Machine learning evolved out of artificial intelligence as the mechanics under artificial intelligence. Artificial intelligence uses the machine learning. Machine learning uses data mining. It's all one big machine doing it. It's basically a set of computer-based algorithms. It's based on statistical modeling. They look for patterns. It generates ideas, potential solutions, probable futures. Well, you'll see. And the key element to machine learning that separates it from what we have been evolving up till then, we've been doing this kind of stuff since the 90s, is that it's going to make its own changes. Now, I'll show you that here in a couple of slides. And the term supervised and unsupervised means that supervised, I'm telling it what to do. I'm guiding it. Unsupervised is going all by itself. So why can we now use machine learning? If we've had it around for so long, what happened that suddenly we can use it? Well, for one thing, just like everything else, it got monetized. Commercial companies decided they can advertise machine learning. We use machine learning. We use artificial intelligence. They're not really, in many cases, using artificial intelligence, but it sounds good and it sells. People, hell, I'm going to get something. They're going to design my house using artificial intelligence. Well, the real reasons are this: data mining. Data mining has matured. You'll see the evolution coming up here. And machine learning, it uses data mining as its basis. There's also the Internet of Things. What about the Internet of Things? Machine learning requires data, big bunches of data. And the Internet of Things does nothing more than to provide data, stream data in constantly from all sorts of sensors everywhere. Everything that's connected is streaming data. Your house, your Echoes and Alexas and Siris and all that, all streaming data. Once you got the technology, high-speed data transfer and technology behind it, you can now stream the data that makes machine learning worthwhile. The visualization, the data visualization of what we're looking at, the data and the minds and all that. So we come up with all these great insights. We got to show them to people so they can do something with them. That means graphs and charts and so forth. That all comes from the research done by Business Objects and Cognos and MicroStrategy and I can't remember the other one, Tableau. All of these guys come up with ways of presenting the data, building data cubes and doing slicing and dicing and so forth. Then, of course, there's the analytics, all the statistics and the mathematics using Python and R and S languages. But really, what is underlying it all that is now fully matured because we have all the technology behind it is good old big data. We can handle massive amounts of data, and that changes everything. It's a whole new world, and now machine learning makes sense. So the advantages: list all that data, no human intervention, eliminate biases, insert biases now, identify anomalous behavior. So here's an example. Now, what I'm using is fraud analytics, partly because I've worked in fraud analytics, but you're probably all familiar. If you've got credit cards, you may get a call every once in a while, and somebody will say, "Were you in San Francisco yesterday?" And you say, "No, I wasn't." "Okay, we have a charge on San Francisco. Is this yours?" And you say, "No, it wasn't." And they say, "Okay, don't worry about it. You're not going to be charged. We're going to give you a new credit card. So, we'll go catch the guy." That's all done with machine learning, with fraud analytics. And how does it work? This is how machine learning works. You want to grasp this, get the concept behind it. I'm sorry, these are some of the, wrong slide. These are some of the machine learning applications you have had. You may not have known that a doctor says, you may be in trouble here. You may have this infection. This is very widespread in the medical industry, using machine learning to identify, based on certain symptoms, various infections that you might have. What you definitely have used is the product recommendations from Netflix. You should watch this movie from Netflix. Netflix recommends these. Amazon, you're buying this. This is some other things you might buy also. You bought this. Other people who bought this bought these things. That's all done with clustering through machine learning. Association. You've called, right? You call and it's a robot, and it's so sophisticated now. Used to be, you know it was a robot. You knew it was recorded. Flat voice and everything, no intonations. Now it's hard to tell. I get a call and somebody's raising money for something. And I say, okay. And as soon as there's a pause, I ask them a non sequitur question. So do you think it's going to rain here in Florida? And the response usually is, oh, I'm sorry, I didn't catch that. Could you mind repeating that? So I say, yeah, do you think that that we'll be having colonies on the moon within the next 10 years? And the voice then goes on. Oh, well, I don't know about that, but, and then they start again. I say, you're a robot. See, if a real human being, they'd say, I'm not sure I understand what you're talking about. Could you? But they're so real, it's hard to tell. That's all. All of that is machine learning. I worked in a design thinking group, and we were designing those responses. The end result of the responses that went onto the actual phones would look nothing like what we had, because the machines learned how to do it and did it better than we did. Some other things that you're familiar with: voice recognition and facial recognition. If you fly anywhere nowadays, you don't have to show them their passport. You just stand in front of the camera and they say, okay, you're good. Big green check comes out over your face and you walk in. First time I went to that, I had my passport doesn't have a beard on it. And so I thought, okay, they're going to check me. And so I put my face in there expecting them to say, go talk to show the passport. Nope, they said, you're good to go. They recognized me even though I had a beard. You all are familiar with the spam. That's really cool. You know, if you say something is spam, it'll also catch anything else that's similar. If you kill something without opening it, it'll start picking that up as spam. It's getting more and more sophisticated. And of course, the good old virtual assistant. There's your Alexa or your Siri or your home or all those things. That's all machine learning. So now you know what's out there. This is the data mining process that it's on which it's based. This has been around. I think that this came from the organization that put this out back, the early 2000s. It's been a while. It's been out there. Now, what I want you to do is you say, well, I don't do data mining. You know, I'm a business analyst. How do I learn to do this stuff for data mining? That's all new and it's foreign. And, watch these 6 steps and relax, because you're going to see an awful lot of familiarity. The first thing we do when we're building the data mine and the models for the data mine is we understand the business. What is the business problem? What questions need answering? What is the environment? What's the situation? Well, if you're a business analyst, that's the first thing you do. I've written a lot of things about the primary job of business analysts is to find the real business problem, not the requirements, but the real business problem. Now, once you have the problem defined, then you go get the data, right? Go ask people, do interviews, collect the data, look at reports, etc. Define where that data is that I can use to solve the problem. So you're doing that now. Now, something that you may not be doing, unless you worked on projects that built or maintained the data warehouse, where you worked in ETL, extract, transform, and load processes, you probably haven't been involved with cleaning the data. Let's let the DBAs worry about that. For data mining, and you have to assume all of this applies to machine learning as well, you have to figure out what it has to do to the data to make it clean enough for us to use. That there's a lot of aspects. We're not going to get into the details of all of the elements of creating and transforming, extracting, and cleaning the data. But that's all requirements. You have to define the requirements to do that so somebody can write the code that will do that. Then we get to the modeling, and some data scientists and data analysts over there writing with R and Python, they're writing the statistics, they're creating an algorithm. You're probably not involved with that other than answering some questions. But then they're going to be saying, this is what happens. This is what we will predict. This is the pattern. And you're going to say yes or no. This is going to be right. That answers the problem we need to answer. Does that sound familiar? Replace number 4 there that says modeling, replace that with software. So you do all that except for cleaning the data, define the requirements, they write the software, you check it out to see if it's right. The final step is the deployment, and be deploying software, but most software goes out into production and is run, the accounts payable is run every 2 weeks and so forth. For the machine learning, we have a one-off or a continuous. A one-off means tell me all the visitors to Cape Breton between 2015 and 2020. This one, we're going to get one answer, maybe some other information, but it's just one shot. Marketing has been using the one-off of this for decades, back when we were doing this by hand. You say, okay, cool, Steve, that's data mining. Where's the machine learning involved with this? Okay, you can see there's a lot of manual labor there. You can see that you've got to, clean the data and you're going to model it. And in here, between 4 and 5, just as you would if you were writing software, you're going to evaluate the results, tell them what's wrong with it, and then they're going to change the code. And then they're going to do it again and around and around. Between 4 and 5, there's a lot of manual labor going on. Machine learning eliminates that manual labor by determining that this does not match what it's supposed to. I'm going to go change something so that it does. Not only that, but that's just the code. The machine learning is also going to go up to the data and say, hey, the data tells us something different than we expected. We're going to change the code based on the data, eliminating an awful lot of human intervention. That's machine learning. That's what we're doing. All those steps, but the machine's going to pick it up. And what does it look like? Here's the fraud analytics I gave you the introduction to. We start off by gathering data from all activities and credit cards everywhere in the world, trillions of transactions. That is fed into a model, piece of code, an algorithm that has been written to identify potentially fraudulent information. Where do we get that? From our heads. We're human beings. We're putting it in there. We're telling them this is a fraud, this is a fraud, and this is a fraud. It then generates a list by going through all that data and saying, here are the things that I think are frauds based on, I think, what you told me. I'm not sure, but there they are. That is then sent to us, human beings. Oh, we look through it and say, oh no, this wasn't a fraud. This was okay. And oh, that's this one you missed. This was a fraud. You didn't get this one. And we mark it up. Just like grading a paper. Except instead of grading a paper, you give it a grade, then you go on to something else. We're going to say, okay, that's cool. Do it again. Now, what the machine learning does is take that information and modify, make changes. Now, instead of the human being making the changes, the code is going to change based on the feedback we provided it. Then it's going to do it again. We're going to go through a second time, and each time through, we're going to get fewer and fewer and fewer mistakes. In fact, as we do this, the machine learning is going to come up, the algorithm is going to come up and say, here's some fraud. We look at it. No, that's not. Wait a minute, it is. They found a new form of fraud, a new anomaly out there that we weren't looking for. We didn't tell it about. How did it know? Because it's going through the data. And eventually, we're going to disappear, and the machine learning is going to do it all. That is machine learning. That's a little spooky too. You start thinking Arnold Schwarzenegger here. So the idea is that we are going to map the data mining analytics processes that we have. We have 6 right now, and a couple more that are still being worked on. The oldest and most common, I used this back in the early 70s. It's called descriptive analytics. We just data about, you've done this. If you've done any kind of data processing, you've done descriptive analytics. Here's the monthly report on what happened last month. This is descriptive analytics. What's going on? What's happening? Using machine learning, not to a large degree, but we can go through larger amounts of data all inside to determine some trends that we might not have been able to do by hand, by ourselves. Now, we have things, the sales went down. The descriptive analytics tells us that Bed Bath & Beyond is crashing. We run diagnostic analytics, and they tell us that we have $422 trillion worth of liabilities and all those coupons that are sent out all the time. If everybody turned all their coupons in at the same time, that's how much we'd have to put out. That's why we're having problems. No, this is not true. I'm just making this up. So we have diagnostic analytics that will look at previous patterns and identify why things happened. And that's been going on now for a couple of decades. The big one today is predictive, and it's been for the past 10 years or so. What's going to happen? Now, predictive analytics doesn't tell you exactly what's going to happen. It says the probability of this happening is this. The probability of that happening is this. Now, in the old days, we could do predictive analytics, but it was only based on what we did, not anything else. Machine learning now can add in a lot of other factors, as you'll see. Now we know that this is most likely going to happen, and this is not good. What can we do to prevent it? And it will come up with ideas. This has happened at this other place, and this is what they did, and they survived. If we do this, we could possibly double our revenue. So the prescriptive analytics tells you how to go about doing it. What are the possibilities you have? The last one, and we're on the fringe of this is really exciting to those of us who find these kind of things exciting, and that is behavioral analytics. You have the computer put out a little thing on the screen saying, Steve Blaise in cubicle number 7 is acting strangely. I think that he may be committing a fraud, or he may be embezzling funds. By my behavior, because it's anomalistic behavior. I'm not acting as I normally do. Using sentiment analytics, we can combine and say, anybody who acts in this particular way is probably up to something. Just as you might have a child, and you can tell by the way they're acting, there's something up to something. Sammy, I didn't do it. Oh, he's up to something. And we're taking that concept and putting it into a machine that will look at behavior of millions and millions and millions of people. Machine learning is mostly used in the bottom ones. Behavioral analytics is pretty much all. We couldn't even think of behavioral analytics until we had machine learning tools to work with. Descriptive analytics we've been doing for 50 years and so forth. So there are a number of challenges, 6 challenges that you will have to face as a business analyst. The first challenge is, am I going to use machine learning in the first place? Things to think about. It requires a massive amounts of data. You have to have access to data outside the organization to really make it worthwhile. You have to have big data, massive amounts of data, and you have to have the ability to transform it, the computer power. If you don't, it's probably not a good idea to consider machine learning. With machine learning, the algorithm is not always easy to understand, and what it does is not that much easier. In fact, it's more difficult to find out why it makes it. And then you've got to explain to management, our algorithm says that this is most likely going to happen. And they're going to say, well, how'd you come to that conclusion? And you have to be able to answer that. And, can you do it? Do we understand what machine learning is? And really the answer is probably not. So if we can't live with the idea of not being able to say to management, this is why it's happening, we might want to use something other than machine learning. If we don't ask the questions right, you're not going to get correct answers. So you have this chat GPT, and they keep telling you, it'll answer the questions, but if you don't ask the questions right, you won't get a good answer. Okay? Can we maintain control over the data for that long term? Privacy issues, and so forth. And will we be able to provide rationals for the predictions and decisions that we want to see, or that we do see? Let's look at a comparison of what you're used to, the rule-based systems and machine learning.
We got discrete logic. I wrote the logic for the code I had, and I knew it had to be 100% precise because if it didn't, the machine rejected it. The computer said, error, fix it. It had to be 100% right. And I knew that when I did it, it's going to run over and over and over again, and I could predict exactly what it was going to do when it did it. All the rules of all the systems that are out there, the transactional systems, were determined by human beings. And we use the rule base for predictability, but we say, if these are the things that happened going for the past 10 years, we can predict they will continue to happen. And therefore, if we've been gaining 0.1% increase in revenue, we can assume that we will continue to get 0.1% increase. No factors, other factors than that, because we don't know. Machine learning, on the other hand, takes indeterminate data, data from everywhere, data we don't have any control over, creates the rules itself based on the data and based on the patterns that we've given it. Its predictability is based on the most current data that it gets from all sources. We identify a source of data and it takes it from there. On the other hand, unlike the earlier statement that we thought about machine learning as a positive thing, it is now, we understand, more susceptible to unintended or hidden data biases. If you have it, it goes out and scans through Facebook or Twitter, the results it gives you in ChatGPT or any place else might not be what you want to hear. You might find that the machine learning is telling your ChatGPT to fall in love with you, which is the now story that they're talking about. So you have to decide, first of all, to use machine learning. Then you have to come up with the questions. And as I mentioned, with ChatGPT, it's coming up with the questions, the prompts. You got to come up, ask them right if you want to get the right answer. So what kind of questions have we been looking for today? Well, we're going to improve the systems, make them better. Six Sigma, a little improvement here and a little improvement there, and continually improve, right? Those are the questions. So our questions are constrained by the confines of the organization and its processes. We no longer want to do that. You can't do that with machine learning. You're wasting the power of machine learning by doing that. So as a business analyst, you have to start coming up with other questions. What possibly could go on in the future? How could I ask what's going to happen? What are the questions that about what might be tomorrow? Who's the alpha customer? How do I find the alpha customer? What is the alpha customer doing? What is their level of influence? Of all the influencers out there, which one would be the best influencer to use? And as Bud Light has just found out, which one might not be a good influencer to use? Foolproof decision, in quotes, I say foolproof. That means that when you come up with a decision, whether it's right or wrong, the decision process and the data on which it's based is unassailable. You have justification for that decision, and it's solid. That's a foolproof decision. I can show you why we came up with this decision. If based on other information that we didn't have at the time, it's wrong, okay, but it's still justifiable based on the information we have. And it's not just based on the information I have and I can get, but the information the machine learning can get me. New revenue streams. Hey, you know, we're Bread and Bath and Beyond. We're going out of business. We need new revenue streams. Machine learning, tell us, what kind of questions would you ask? But the really thing is the next big thing. And here's an example. Most of you have seen movies. It takes 2 to 3 years to make a movie. Any movie we're making right now, the next 4 or 5 months to film it, but then you get all the production and all that. It comes out, it's going to come out in 2027. So the question is, what is the popular movie going to be in 2027? Did you ever think of asking that question? Well, obviously, if you're not movies, you wouldn't, but that's the kind of question we need to be asking. That gives machine learning the power. If we can't come up with those questions, we're going to be left behind because people are. Some people are going to say, not only what is the popular movie going to be in 2027? Is it going to be a Western, a mystery, a film noir, a sci-fi? Is it going to be another Star Wars? What's going to be the big popular thing that's going to sell millions in 2027? Because I want to make that, whatever it is. Not only do we do that, But then we want to find out where we're going to get the data to do that. Basically, you want to, as a business analyst, say, if I could access all the data in the world, all of it, what questions would you ask? Obviously, you're going to say, what's the weather going to be tomorrow? And, when are we actually going to land on Mars or something? Am I going to be around to land on Mars? You might ask those kind of things, but really, where are your questions right now for the organization as a business analyst are constrained by the business that you're in? What if it weren't? What if you could have all the data? Now, you may not be able to get all the data in the world, but thinking about that, expanding that goes. So speaking of data, we have descriptive data analytics, and that's what's going on right now, reports and so forth. Data we know from our own databases. The questions come from our observations of what's going on, about the problems somebody says we have. This is what's happening. What we want to know is what isn't happening. So challenge number 3 is to identify the current problems. What's going on right now? We're not meeting the KPIs. Now, the major drawback with the challenge, the biggest challenge is descriptive analytics only shows what has already happened. As I say, we've been using it, monthly reports, every single monthly report, your status reports, those are all descriptive analytics. If you spend any time analyzing them, that is. What we want to know in terms of challenge number 3 are, can we anticipate problems or issues that might come up next week, next month, next year? Can we identify problems we don't know we have? How about the problems we don't know are problems because somebody formed a workaround 5 years ago? It was a problem back then. They couldn't fix it, so they did a workaround, and we're still using the workaround. If we could fix the problem, we could reduce expenses, for example. But we don't know we have that problem. And how about some recommendations of what to do about it? That's where we're going. Now, instead of just talking about how we can improve something that we already know, but what about the things that we don't know about? And that's what the machine learning is going to help us in descriptive analytics. Help us ask and answer the what if questions. And the big deal is, and so I'm going to define the big movie in 2027. What data do I need to do that? And we did a exercise with a company for that. And it was really interesting, the data that's available, we could come up. And I do believe that it's possible. I don't know that anybody could get the data, and I'm not sure that expense-wise it'd be worth it. You might have to spend more money than you'd make back from the movie just to find out what movie would be popular. But it would be, we did the same thing. How would you know at running a hotel chain in Singapore? How would you know when you're suddenly going to get a bunch of people coming in for an event and know it in advance because they're going to book it that much in advance? So they go to one of your hotels, which is overbooked and stretched, and we're not giving good service. The other hotels are empty. How can we do something about that? And we actually found the data to get. It was all available. So here's a wealth banking dashboard, also incidentally from Singapore. And you're the business analyst. You have to say, what could I put on this dashboard that will help the wealth banker be better at the wealth banker's job, the relationship? And so over there, left-hand side, under the picture of the client, is all of the correspondence. Everything that this client has said to anybody in the bank is right there. So that if I don't see this person for 6 months, I can refresh myself to everything they've talked to in the bank, whether I did it or not. So the question is, and there's, there are transactions, there are recommendations of things that they're doing, how their portfolio is doing now and how it's going to do in the future, what they might buy, what other people are buying. So where's that data going to come from? We're going to have it in the data warehouse in our corporate and our transactional data stores. A lot of that data is going to come in, just like it always has. But then we're going to add information from the data lake. That's our big data. We're going to add in things like emails, and we're going to add in Skype and scrape off Facebook and Twitter and the Internet of Things there, blogs we're going to bring in. All this information into the data lake, machinate it around, play with it, and then we're going to post it on the dashboard to give the wealth banker an up-to-date. And as for that that collection of all of the interactions the client has had, we're going to have to go through emails, voicemail texts, video recordings, audio recordings. He does a Skype. We want the Skype recording. So if I want to see, he did a Skype back in July 2022. Find it in the list, bang, bring it up, and it pops up and shows it to you. That you can't put in the data warehouse. That's in the data lake. All of that is big data. All of that is unstructured data, and all of it is handled by machine learning. Machine learning is the machinations. It takes all of the data, moves it around, puts it into a staging area, which is then put onto the dashboard. All you need to have is the imagination to identify, hey, we can get data from there. We can add this to the dashboard. They'd like to see this. Where can we get it? The diagnostic data analytics, which tells you why things happen. This is where you get the dicing and slicing and drill down. And that brings up the next problem, challenge, which is, what are the issues in solving problems now? What do we have to do? Where can we find similar solutions? So the drawback is that we need some kind of reference. Clearly, we can put the entire of the PDM5, I think it's called, all of the symptoms and the most likely disease. So somebody comes in, reports these symptoms, machine learning comes up and says, that's some strange disease. It's only been 1 in every 14 million people have it. And this is how to solve it. So we have prescriptions. And we have, that TV show House, you can come up with all these things. Well, we have machine learning do it. It hasn't been done yet, but the technology is there to do it. So we can now start looking and being aware of, as business analysts, when we're doing this, the data biases, that it'll come up and give you a particular diagnosis that doesn't match, but it's just what's been talked about, for example. There's insufficient data to describe the problem, so they give you an invalid diagnosis. The people who get the diagnosis misunderstand it. You didn't present it well enough. You'll find, as a business analyst working in machine learning, you'll find an awful lot more work you're going to be doing in data visualization. It's not something you just throw off to the UX people. Also, the people who you use diagnostic, and we've noticed this over the past, assume that the algorithm is infallible. Whatever the algorithm says is right, even when it's against common sense. The business analyst has to be there to apply critical thinking and skepticism and say, no, we got to look at this again. Here's the predictive data analytics. We all know pretty much what's going on there. There's the, we use regression analytics to come up with a prediction, a potential of how possible this particular future might be. That brings up more challenges because management wants those predictions. So we have to make sure they understand that this is not the prediction, that it's 80% likely, but that means 20%, it might not happen. And now you've got 4 possible futures, 77%, 76%, 74%, 72%. You still have to make decisions. And that's something the business analyst has to be on top of, okay? How do you solve a problem that hasn't happened yet? It predicts that this problem will happen, but how do you solve it, okay? And there's the whole bottom line in predictions. It's difficult to make predictions, especially about the future. This has been attributed to Niels Bohr or Yogi Berra, but it turns out that it's actually an old Danish proverb. And finally, prescriptive data analytics. Certainly, if I know I can put the PDM5 in there and I have all the symptoms, we know what we need to do to cure this disease and to cure that one and what pills we'll take. We need penicillin there and 2 aspirin and call me in the morning there. Put the lime in the coconut and so forth. So we know what to do. So why don't we tell the machine learning, put it into the databases? We can now, because a lot of the prescriptions and the ways we do things are not data. They're not the structured data out of the databases. They come up, prescription pads, for example. If we can put all that knowledge, take it right out of there, do Vulcan mind melds on all the doctors and get all the prescriptions, sure we could. We have been doing it. IBM and EDM have been using it for self-correcting servers. So the challenge is the right prescription. What to do about it? Not just that it might happen, but what to do. How do we get that prescription in there? So the machine learning tells you this is the most likely thing you should do to solve this problem and resolve it. You as a business analyst then have to lay it out. This is what we do. We do this, then this, then this, then this. Machine learning may not tell you that. And again, we have to be aware of the biases. What is the impact of doing that? Machine learning doesn't tell you the impact. It just looks at the statistics and says, this is what it's going to be. We have to look at the human impact. Yeah, we could lay off, close down that plant, but we're going to be laying off 3,000 people. Maybe we want to double think that computer doesn't care. In the end, there will still be a decision to be made. And that's the thing that the business analyst keeps in mind and has to pass on. So what is the business analyst thinking about now? What are the questions that we need to really get answered? What are the real questions? Not just the questions that I can answer because the data is there. Management wants to know about new product ideas. How can I get that for them? Manufacturing says there's slowdowns coming all the time. Nobody can seem to figure out why. What can I do to figure that out? What's the best way of presenting data so management understands what it has to do? And probably the biggest question that business analysts are asking right now is machine learning going to take my job away? So here's some rules. Have a clear purpose. Make sure that you have data. Remember, the more data you have, the more accurate it will be, but the more likely that you'll have biases. Experience and opinion can be included in the algorithms. You want to record them as data, but you can say, in my experience, this has happened, and put that into the machine learning algorithms. Cleanliness is next to godliness in terms of accuracy for machine learning. Bad data is garbage in, garbage out. Ensure a solid pipeline from the source of the data to the algorithm repository so it can be used. And you're still going to need metrics. All the metrics you use as a business analyst, you're still going to have. And rule, make sure you're ready to justify the decision that you have made. Choices you have to make, recognize a problem, what questions are you going to ask, how to know a problem is solved and the question is answered, and is this really a job for machine learning? Or, as we have noted, many of the things that say on machine learning aren't really. They're still good old-fashioned rule-based. But people in the world don't know that. And if you tell them it's machine learning, they'll pay extra money for it. So here's machine learning. We want the BA before and after. It's not going to take your job because you have to define the problem, ask the questions, delineate the data sources. You have to determine the correctness of the data. When the machine learning finishes, the algorithms are done, you have to validate the solution. You have to define the insights, define how to determine the insights, define how to make the action actionable, the results that come out actionable so management can do something about it. And of course, support and justify the results. All of this means that what we're doing is the same thing we always have done. We are decision support. We're helping management make decisions. Here's things you can do. Assume anything can be done. Expand your mind. Just, let your curiosity flow. Just think that the answers are in there. Refocus your attention on the data instead of the process. Forget the processes. Processes have already been done. There's very few who are going out and greenfield new processes. It's all data. More companies are digital transformation, are becoming data-driven, are having data-driven decision-making. Move from just plain analysis to analytics. Hone your skepticism. Apply critical thinking. Do a lot more visual thinking. Machine learning is only a tool. And if you don't believe me, ask ChatGPT what effect machine learning is going to have on your job. And now, hopefully, I ended in time for some questions. Please do ask the questions in the chat, and you will be asking me the questions because I can't read the small fonts.
Thank you so much, Steve. Some people are already asking ChatGPT questions already. Okay, we have 2 questions here right now, but please, if you have questions for Steve, drop it in the chat. I would read it out to him and he would answer very quickly. And also to stand a chance to win, I think I hear myself echoing. To stand a chance to win one of Steve's book, we actually have 2 to give away this evening. Fill out the form in the chat. You can do that very quickly while we take the questions. Okay, the first one here says, does the essence of teamwork and collaboration change because of machine learning? Does machine learning influence the evolution of waterfall, agile, or hybrid?
2 questions. The first one is no. You saw the curve, the cycle. The same basic cycle that we have in the standard SDLC. We're going to have to collaborate with the business to understand their problems and get their questions. We're probably actually going to be more collaborative with the business. The business analyst the emphasis is going to be more on business than on the IT side, because we have to sit down with the business people to find out what they really want to know. Help them understand what's out there, what they can ask. Tell them that, yeah, you can ask what the best movie is going to be in 2027. You can ask that. Help them and read between their lines. They're asking the questions, but they're not coming out with it because they think, oh, we can't put that on a computer. So there's going to be a lot more collaboration with the business than you are right now with the typical rule-based systems. You may have as much collaboration with the developers. In this case, the developers are your data scientists and so forth. And that's in explaining why they're doing it, what they're doing. The more they understand, the better they can come up with they can tell machine learning what to do. So I would say, from what I've seen, there's not any less collaboration. But, and I expect that as we move ahead, for the business analyst, you will find more collaboration. If you take it, you have to embrace it. You have to say, yeah, I'm going to do it. Now,
let me read it again. Hold on.
Yeah, you're asking between waterfall,
does
agile,
machine learning? Yeah, let me repeat the question.
Go ahead.
Does machine learning influence the evolution of waterfall, agile, or hybrid? Steve, did you get the question?
Yes. Yeah, I was thinking. Okay. I'm sitting here typing in into ChatGPT. See what? I can't see. Machine learning might be in waterfall, in linear. Waterfall is just a form of linear. In linear, the requirements are done up front as a big bang type of thing. We end up with the requirements at the end, and then that's passed on. And I can see machine learning being used by the business analyst to get, as we say, we've got the data all over the place inside the organization. There may be data. We might be doing systems, web-based systems, for example, talking to the customers, digital transformation, allowing the customers to order online. And what we're going to post on that, how that's going to look, even to the colors on the website, we might use machine learning to scan through all of Facebook to find out what the current popular color is. So we may be doing a lot of machine learning, but it's not going to change the evolution. It's just going to change the amount and accuracy of the requirements we get. As for agile, I don't see any impact whatsoever. And hybrid, the same thing. But the only impact on traditional software development I can see is possibly getting in to help in the development of requirements. Now, in the writing of code, we already have major advances, but we've had those for years. I've worked with tools, 5GLs they were called, where I made specifications and basically filled in blanks and it wrote code for me. Then I went in and read the code and tightened it up. So that's been going on for a long time. So I don't see that making any major changes. We're talking in the field about having, hey, ChatGPT, write me some code that will do this. And, that's possible. So if in that case, you could say that programmers who aren't writing ChatGPT code and machine learning code, they're the ones who are more likely to lose their jobs than BAs are. So that's just some thoughts.
Yeah, thanks so much, Steve. I'm gonna have a question here. So this is my own question. You went through all the types of talked about descriptive, diagnostic, and all of that. And I was wondering, in which of those buckets does generative AI fall into, like ChatGPT and the likes?
They could be any one of them, and we can combine them. I listed them in order of their age. I mentioned descriptive analytics has been down. We didn't call it descriptive analytics. We didn't know it was descriptive analytics. Some PhD someplace along the line said, hey, you guys are doing descriptive analytics. So right away, I put it on my resume and got better jobs. Because it's a good phrase, right? Hey, I know descriptive analytics, but it's been around. The newest one is behavioral. We're still working with that. Now, so I listed them just in that order, not necessarily that they're exclusive of each other. I could have given you a slide that showed various different things. Well, here's security. We want to know when the next ransomware attack is going to be and whether we are susceptible to it. So if I ask, say, ChatGPT or any other generative AI, they're going to use descriptive analytics to determine where and what the ransomware attacks are, the composition of ransomware, where they're happening right now. They're going to do the trends of it over time. They're going to do diagnostic. You're going to use diagnostic analytics to look at the organization's vulnerabilities and see if they are vulnerable to, if they have the ingredients that a ransomware gang would want. And they got money, for example. They'll use predictive analytics to predict, based on the information we have, where is the next round? Because as we have found out so far, the ransomware attacks happen in clusters and in waves. So right now we're in a slough, but there'll be a lot that we can predict that come around July, there'll be a big burst of ransomware attacks. So we want to predict where it's going to be. That would be predictive analytics. And we might even throw in some prescriptive analytics to say what we can do about it. So in one question to generative AI, assuming they could do it, generative AI, the AI might use 4 different types of analytics to put them together to get you the one answer. So they're not exclusive.
Thanks so much. And we have one more question here from Simon. What would be your advice in terms of tools, application, recommended reading for a BA to start exploring use of machine learning in his or her job?
I'm a engineer, programmer. I wrote code for 25, 30 years. And I stopped writing code when they kept coming up with a new language every week and I couldn't keep up. So mine, I try something where I don't have to write code. But so my answer will tend to be somewhat more engineering. But my first reaction to somebody who says, what do I have to get into to better understand machine learning? Python. R. R might be a little challenging if you're not mathematically inclined in statistics. I could only get into R a certain way. And then some of the stat pack stuff that they talk about, I had no clue. You know, I got through math and that I needed to for engineering, but you know, this is good stuff. So that would give you the basics. If you know Python, you know what's going on, why it can do what it's doing. Tell you what, you've got my email address up there. If you write me that question, I'm trying to go through in my mind some of the documents and things that are out there. There are some machine learning for dummies type things. I don't know if there is one, but there are some that do explain. And if I can't find anything else, I'll send you some stuff I've written. So but when you write the email, please ask the question. Don't say, hey, Steve, send me what you said you'd send me, because I won't remember. Just say, hey, Steve, what do I have to do to get as a BA to get into machine learning? And I'll send it. Anybody who wants to do that, I'll go ahead and send it to you.
I'll send the email and then we'll share with our mailing list.
That's fine. That'll work.
Yeah. So you can connect with Steve. You have his contact up here on the slides. Thank you, everyone. Thanks, Steve. I can't see any appreciation for Steve in the chat. Steve, on behalf of the board members of the IIBA Halifax, I want to say a very big thank you for making out time to prepare these beautiful and informative slides and coming to share your wealth of experience, like 55 years, oh my goodness. Thank you so much. And yeah, our audience, they are saying thank you. Thank you. Renee,
Be glad to come back at some future date if you want me back. I'll come back.
Sure. We're waiting for your new book, and we're going to come explore your new book. So
Thank you
so much. Yeah. Thank you, everyone. Good night, everyone.
Thank you.